Okay, this is a normal distribution question. The distribution is symmetrical about the line x equals 35. So that's going to be the mean of the distribution. Point of inflection at 31. Let's just try and mark that on there. So 31. That means that will be one standard deviation away from the mean. So that distance there would be one standard deviation. So in other words, the standard deviation must equal 4. So our distribution we can write down as this mean of 35 and the standard deviation is 4. Now what we've actually got to do in this question, it says 50 independent readings of x are made. Show the probability that at least 45 of these readings are between 30 and 40 is less than 0.05. So we've got to find the probability of a reading being between 30 and 40 for a start. So if let's try this highlighter pen. So between 30 and 40. So we want to find the probability of a reading being between 30 and 40, which looks quite high. There's a lot of that distribution being shaded there. So we want to find, using our normal distribution, we want to find the probability of getting a value between 30 and 40. So if you use your calculator to do that using the cumulative normal distribution, that should work out as 0.7887 to 4 decimal places. So that's the probability of getting a value between 30 and 40 in this distribution. And now the question is talking about there being 50 independent readings of x, and you want to find the probability that at least 45 of these readings are between 30 and 40. So now this now changes to a binomial type question, because there's 50 readings being made. There's 50 readings being made, and the probability that each one is in the region 30 to 40 is what we got above, which is 0.7887. And now we normally would write this, but we shouldn't really write x again since we used x for the normal distribution. So let's call this y this time. And we want to find the probability at least 45 of these readings are between 30 and 40. So we want to find the probability of our binomial distribution of getting 45 or more. So that's pretty similar to the previous question we did. You want to do 1 minus the probability of less than or equal to 44, because your calculator always gives you the less than or equal to value. And if you do what you did in the previous question, do the cumulative binomial distribution on your calculator, I think that works out as 0.0322 to 3 significant figures or 4 decimal places.